I think we can get started. So this talk is about the challenges and solutions when you trying to deploy blockchain applications onto Kubernetes. Specifically, I will be talking about the Hyperledger Fabric. How can you actually deploy and run your applications on Kubernetes, and what kind of problem you might face, and how can you solve those problems? Actually, I can talk in Chinese. I don't know. I assume you want in English? Oh, okay. So who else wants English? I can continue in English. Okay, that's fine. Actually, that's what I told the organizer. I'm going to be using English. Okay. Just a little bit of introduction by myself. My name is Tong Li. I work for IBM as senior software engineer. I've been working for IBM for a long time. A couple of years ago, I was working on OpenStack, the cloud. Now I work on Hyperledger Fabric. I am one of the 4 Fabric Cello committers. So Cello actually, I'm not going to focus on Cello in this talk, but I just want to give you a little bit introduction about Cello. Cello actually is an installer or deployer for Fabric for the products actually under Hyperledger umbrella. So if you want to deploy Fabric network onto some kind of environment, for example, Kubernetes, or just bare metal machines, and you can use Cello to do that. So you can find me on GitHub. So I think we have to talk about a little bit the agenda, so you know what content we have for this talk. So first, I'm going to be just briefly talk about blockchain technology, then what is unique about it, then the differences between different blockchain or ledgers or applications. Then I'm going to talk about Hyperledger Fabric, because this is the product that open sourced a couple of years ago. It is very different compared to other blockchain-based applications. Then I will talk about what's the reason that we want use Kubernetes to run Fabric. After that, I'm going to talk about the challenges and the solutions, and some good news, and we're going to have a little bit of time for questions and answers. Okay, blockchain technology. Actually, after I signed up for this session, I was thinking, what is actually the best way to describe blockchain technologies? Then I find actually this description from IBM.com. If you go to bluemix.com or IBM.com, you can find the blockchain solutions. Then you will find this quote. It says, blockchain can do for business what the internet did for communications. Actually, I think that's very true. The invention of the internet actually changed the world. I may also add that the mobile devices, right, the cell phone, the mobile devices actually really changed how people actually live their lives. Right? Those are the big changes. Now, people put actually blockchain technologies in that same category. So if we I mean, human being use the technology the right way, I believe this will be a revolutionary technology. So it also says every second of every day, business exchange value with supplier, partners, customers, and others. By value, what we really mean is the goods, services, money, and data, and whatever actually has values. For example, you have a blog, right? You post it, then actually people go in there, read your blog, says, yeah, I like it. Actually, that also has some values, right? All those things, eventually will have something that people probably feel, as valuable. So when people actually exchange those values, you actually create a transaction, right? And you want to record those transactions actually accurately, so that those transactions reflect the real world, right? So successful transactions need to be fast, precise, easily agreed on by all the parties, right? Let's say you're gonna send money to somebody, and all the parties, probably include bank, will have to agree that the sender sent $10 or $100, right? You cannot have a system that the sender says, I sent $100, the receiver says, no, I didn't receive $100, I received 50, right? That would be a problem, right? So you want to be able to actually successfully record those transactions and accurately. So, I mean, people do that already, right? Since the very beginning of the human history, people do transactions, right? Blockchain is just the system or technology that it's a better way to record those transactions. So, what is the unique about blockchain, right? If you look at the blockchain applications, actually, I should have asked, how many people know Bitcoin, 比特币? Right, I think almost everybody. How many people know Ether? Very good. Excuse me? Okay. So how many people know proof of work? That's about half. That's pretty cool. That's very good. So if you know blockchain systems, you pretty much know that all blockchain systems supposed to be decentralized, right? Decentralized doesn't mean it's distributed. Okay, there is a difference there, right? The ledgers are shared. Anything recorded on the ledger is supposed to be tamper evident. So if there's some errors actually recorded, that kind of error should be very easy to find out. Also, if you put a transaction on the ledger, you're not supposed to change that. It will be there, right? You can't change it actually. Before you put a transaction on the ledger, all the parties supposed to agree on, right? So this is the thing actually happened. We're gonna record as such, right? So that's actually very different compared to the traditional way of the digital ledgers, okay? So a lot of people already know Bitcoin and other cryptocurrencies, but those things most of those applications or the coins actually are public. So the transactions available on the network, right? If you actually participate in the network, you'll be able to see all the transactions, right? You may not be able to find who owns that account, right? That takes some effort, but it's not to say you cannot really find who owns that, right? So the data actually on your ledger is public, open to everybody. And there's some other kind of a change that they want to make those transactions to be private or permission based. Only the ones that have the permission are allowed to see those transactions. Okay. So there are certainly different ways to see the data, right? So actually, I asked this question. If you look at all the blockchain technologies, the way that people put the transaction on the ledger, there's so many different consensus methods you can use. The most popular probably is the proof of work. There's some other ways like a proof of stake, proof of elapsed time, and the proof of authority. You know, each of those methods has their pros and cons. So you have to look at the application you're trying to develop to choose what kind of a consensus method you wanted to use, right? Of course, there are some other consensus methods. You know, there's actually so many. So Hyperledger Fabric. I think in early 2015, IBM and other companies started develop this product. They know that not all the business can put their transaction on the public ledger, right? Some of the transaction has to be private, right? Especially when you look at the banks, right? They don't want people to know who owns how much money, you know, who will deal with who, right? You just can't make those things public. So they think about, you know, how can we secure those transactions? I think that's how actually Hyperledger Fabric gets started. So very quickly, they put this product under Linux Foundation, open source the Fabric. So as I said earlier, Fabric actually is permission based. You have to be part of this consortium. Excuse me. It's sort of like you have to be part of this big party, right? You have to belong to an organization that's part of a consortium. So to join that consortium, actually, you have to go through approval process and, you know, sign up and request, allow the existing members to actually approve your request, and eventually you can join the consortium. For the consensus method, my understanding is currently it's some sort of like a proof of authority, because we actually Fabric implement the system we call the ordering system. That system is like everybody, you know, trust this ordering system. When the transaction comes in and transaction send it to the ordering system actually line up every transaction, eventually create a block. So you sort of trust this ordering system and So to me, that's like proof of authority, right? To make that work, you really have to have all the parties participating in a consortium that everybody is approved to be part of it, right? So in the early days, I think the ordering system was using some other method. Now started at 1.0, I think the ordering system used the Kafka queuing system. We also support a solo system. It's like just one node, I mean, if you want to know the details, actually, we're probably going to take a lot of time to drill down to each of the component. But just consider that the consensus method currently Fabric support is like a proof of authority. Okay. The other thing it's quite unique about Hyperledger Fabric is that when we actually build Fabric, we deliver those components as containers, right, rather than the binary code. So if you look at the Docker Hub, actually can find all the different releases on Docker Hub for different component, like a peer, order, the Kafka container image, all that kind of stuff. You'll find many different versions. So I don't think we actually produce the binary and put out the binary for, let's say, for Ubuntu or for others. We simply produce container images and put on Docker Hub. If you're really interested in development of Fabric, you can certainly join the community. Right? You can contribute code and fix bugs. Help out. And of course, if you just a user, you want to use it, I also encourage you to join the Rocky Chat Fabric channel. You can ask lots of questions, and normally those committers will respond to your questions fairly quickly. I mentioned Cello. Cello is one of the 10 Hyperledger projects. The sole purpose of a Cello is to help you deploy those products onto different environments, right? So I'm responsible for the Ansible agent that actually allow you to provision virtual machines from, let's say, AWS or OpenStack Cloud or some other cloud. Provision virtual machines first and then deploy actually Kubernetes onto those nodes, then eventually put Fabric onto the Kubernetes cluster. Okay, so why use Kubernetes for Fabric? As I mentioned, actually, when we designed Fabric, it was designed to run as in container environment. So it's natural that Kubernetes cluster provided this environment, then you want to run those things in that kind of environment. Fabric network is decentralized, like many other blockchain networks. So you can stand up your own nodes anywhere in the world. Then you can join existing Fabric network. Of course, you have to go through the process that how you join the network. It's not like like a Bitcoin network, right? You can stand up your miner just doing it, right? It's quite different. And you can also start very small, right? You can have just one peer in one organization. Then you can join a bigger Fabric network. You start to do transactions and view, what data might be on the ledger. So you can start small, use some CPUs, very little CPU, or you can grow your business that you can add more peers. So, when you look at many blockchain consensus method, like a proof of work, that's very resource intensive. It costs a lot of actually money or power to actually produce the hash code. But Fabric actually is different because the consensus method is more of proof of authority-like. So the ordering system is responsible to line up all the transactions to produce the hash code. So it's not CPU or memory resource intensive, right? So, you can certainly run this. It's not like it's gonna cost you a lot of money to just produce one hash code. Okay, so that's pretty much all the things I want to talk about Fabric and blockchain technologies, because this is really a Kubernetes conference, so I cannot really dive into the details of blockchain or Fabric. So next, I'm going to talk about the challenges and the solutions. Actually, challenges I faced when I'm trying to deploy Fabric onto Kubernetes environment. Even though those are challenges, I'm not saying that Kubernetes is not good, right? Probably Kubernetes is the best out there right now. Okay, so don't take the wrong way. Now you have Fabric, or you have some other, blockchain, systems you want to deploy onto Kubernetes cluster. So what is the first thing you have to do? Right? Get a Kubernetes cluster, right? Right? So basically there are two ways you can do that. One is, go to Google or go to some Microsoft or IBM, say, I want a Kubernetes cluster. Right? That's one way, right? So you just pay them money and say, give me one. Right? So, you can get one. Or you say, forget about that. So I'm going to just get my hands dirty and get a few servers, and I'm going to set up Kubernetes on those bare metal. Sure, you can do that. Right? I remember one actually keynote speaker asked the audience, who do you think set up Kubernetes from bare metal is easy? No one, right? It's not easy, right? I mean, you have to actually to know a lot of things to make that work, right? So actually, I work on OpenStack for a long time, and I contribute to Neutron, to actually make your Kubernetes cluster work. You really have to have very good understanding of networking technologies, right? If you don't know what the overlay network is, then I don't know how you can set up a working Kubernetes cluster, right? So, that method normally is, if you're serious about things, probably you don't want to do that. You're probably going to go to the Kubernetes cluster provider and say, give me one. Even with that method, it is still very difficult. Okay? I don't know how many of you have tried different Kubernetes providers. How many of you tried at least one? How many of you have tried two? How many of you have tried three? From three providers. Okay, so what's your experience? Are they very similar? Okay. Yeah, actually, if you Yeah, I'm supposed to repeat your answer, I guess. So you think you have to use the CLI, right?
Not have to, but I prefer because it's easier to switch. Yeah, because the structure of the command are very similar. So if I want to switch from this cloud to that cloud, it's simpler. Unless I want to write a bot to control those UI things.
Okay. I tried like from four providers. I wouldn't say the names because it's kind of sensitive, right? You're not supposed to criticize those providers. But my experience is very different from one provider to the other, right? In some of the cases, it's just you have to know, the cloud first. You have to add those nodes first. You have to provision those first, then you can add. Then gradually you follow the steps. Then you have a cluster, right? That's one way. The other way would be, going to download the provider's command line tool and now get a certificate and follow those steps. Of course, some other providers actually do a better job. You log into the UI, you say, okay, now I want 3 nodes, I want 4 nodes, 5 nodes. Now, 15 minutes later, you probably have a Kubernetes, right? Some of the providers, I take a long time, okay? So what I'm saying is, even to get the cluster is not that easy. And, sometimes you have to write some a vendor specific code to actually get those things going. So now, let's say you have a Kubernetes cluster, right? You wanted to do things, right? Normally, as a developer, you probably, of course, you can use the dashboard, right? But most of the time, probably you want to use the kubectl to do stuff. To be able to do that, you will need the kubeconfig file, right? To get the kubeconfig file, it's not, you think, okay, well, that's just one file. What's the big deal, right? But the problem is different providers give you different ways to get that. Some provider even say, okay, now get this certificate first, then copy paste those things and edit those files. Now, after a lot of steps, you get one kubeconfig file, right? That's very tedious, and you can make small mistake and then you just couldn't log in, right? So that's actually a challenge, right? Just to get the very basic kubeconfig file. Now I want to check the time. So how many minutes we have left? I guess I can keep on going. So the third one, for the blockchain applications, probably that's also common for other applications. So you always want to save some data, right? You need some storage, right? The issue with the storage is that Kubernetes supports so many different persistent storage. I just have a list on the right-hand side. This is not complete list. You can see the capabilities, the performance, and everything. This is very, very different. Even though when you create this persistent volume, you can use different mode. But the one actually, when you create your cluster and the storage class you have may not support all those mode, right? Now, when you want to mount those persistent volume claim onto your container, actually, in many cases, it won't work, right? If you don't, even if the mounting is successful, right, you probably cannot write to it, right? So you actually have to try many different combinations. Just realize that, oh, okay, this actually won't work. So what I end up doing is that, because I cannot just create a program which works against IBM cluster. I have to create the code actually works against many other clusters, right? So you have to make sure things actually work. So what I end up doing is to set up actually an FS system myself, then create the persistent volume class, right? So that way it will work consistently through all different clusters. So, so this one. I mean, if you have worked on Kubernetes, you probably know that, you know, when you stand up something, you know, you may have a lot of pods. Now you want your pods actually communicate with each other. So you don't want to keep trying to find those IPs, right? You actually want to use the name, right? So that's where the DNS really helps. But the problem is that, you know, to make those things work, actually, for every pod, you probably have to set up the service, right? If you don't, as I showed you the example here, the pods actually, if your cluster actually enable pods also to have an entry in your DNS services, actually the name contains the actual local IP address, which makes that entry actually not usable, right? Because you don't know that before you deploy it, right? That's after fact, right? So, you know, so the only way I see that working is, you know, for every component for a fabric, like a peer, you know, order, or even, let's say, we use Kafka, right? Then you have to set up a Kafka cluster, then Kafka actually also uses Zookeeper, right? So you have a lot of actually components depend on each other, and those clusters have to know each other to make it work, right? And normally when you set up Kafka or Zookeeper, you want to have at least 3 nodes, right? So those 3 nodes have to know each other, right? That's how they communicate. So DNS service actually is important, but you know, you have to set up the services to make that work. Yeah.
Service. Oh, hi. There's kind of a workaround with stateful sets that you can do this with, where you set up a headless service with no IP bound to it, and you have a stateful set connect to it. You map them together, and it'll give you like service-0, service-1, service-2, and they'll be persistent, and you have persistent storage, and you don't have to set up a service for each node in your Kafka thing to get a guaranteed name.
So that way you sort of like, you have to know those names.
You will. It follows a pattern. Mm-hmm. And they start numbering at 0 and it goes to n. So if you have 5, you have 0, 1, 2, 3, 4.
Right.
And it will be service name, I forget the exact DNS pattern. And then it's like service name -1, service name -2, 3, right. 4. So if you have Kafka, you could have a Kafka service, and you would have all the pods exposed by however many pods you created in your stateful set. And then you don't have to manage a one-to-one service mapping for like n things.
Mm. Yeah, okay. Yeah, we probably can talk offline. Yeah, I got 2 minutes left.
Okay.
All right. Appreciate that though. So the other challenge is really because sometimes you do want to actually see things going, the components easily from the dashboard. So Kubernetes dashboard access actually is also an issue. Different providers actually have different ways to launch the dashboard. It's really a less important challenge, but nonetheless, it's a challenge. Okay, Docker issue. How many of you know smart contract? Oh, good. Okay, so Fabric actually support smart contract, but we don't call it smart contract. Actually, we call it chain code. Anyway, it's sort of like a smart contract. But when you actually install the chain code onto the peer, peer eventually create another container instance. Okay, so in a Kubernetes environment, that's not really a pod. It's just a native Docker container instance running in the environment. To be able to do that, actually, you have to have a Docker service endpoint, right? But in the Kubernetes cluster environment, you just don't have that, right? So this actually is a big problem for Fabric. And also you want to run those containers side by side with your peer, with your application. So what we actually a workaround we use is to use the daemon set to actually create the Docker in Docker container for the endpoint. Make sure that the endpoint exists on every node in your Kubernetes cluster. Okay. I think I have run out of time. So, very last one. The other challenge is the application deployment. I told you guys that I work on Cello, which is an installer. So when you deal with like a Fabric, like a large system, and you always have many different components. Those components will have to be deployed in order that it makes sense. For example, if you want to set up the ordering system, right? You first have to set up your Zookeeper, right? You have to make sure your Zookeeper cluster actually working. Then you have the Kafka working. So you have to go step by step. But when you use actually the deployment method of Kubernetes, you don't get that, right? You deploy, then you cannot have all those things deployed in one shot, okay? So you have to have some kind of a sequence to make sure the stuff actually work. One component work, and then you go on to the next component. So actually what we use is to use the Ansible to deploy the first let's say cluster, then we wait until everything comes back, all the service endpoint and the ports and everything, then we move on to the next one. Okay, so the good news is that the Kubernetes has this conformance working group. They're trying to make sure that all the providers actually conform to some certain standards. What I hope they can do is that not only to stop at the API level, they can also consider some usability, for example, some of the UIs, easy to use. So this is really just a wish. Okay, I do have to put this slides on this. Yesterday, my manager sent me a link says, okay, wherever conference you go, you have to add this in your deck. So this is an IBM thing. You can sign up if you're in North America. You can sign up to participate in a contest, and if you win, and you will get a drone. Right? We have 1,500 actually available. So if you're interested, you can go there. If you want to take a picture. Okay, I think we run out of time. If you have a question, want to talk to me, probably after this session is over. All right, thank you very much.